start. Now 4.4 supposed to be on the easy side if you already study, of course, from graphing. So in 4.1 to 4.3, we are given, we start from the equation. We start from the equation and we try to graph it. Now in 4.4, we actually start from the graph, and by looking at the graph, we find the equation or the function. Okay, now I said it tends to be on the easy side because you just need to know what to look for. Okay, what to look for, what to look at. Now let's start, for example, the easy one from number 6. Now I hope you have your book open together with you. Now, nobody have any reason to say, Thomas, I don't bring my book. Right?
My dog ate it.
Because if you don't bring your book, that's the reason that you actually should have your book, because you should be at home. Right? Well, anyway, number 6. Let's see what we really need, what we need to know before we get the graph. First, what's the center for number 6?
1.
Are you sure?
Actually 0.
It's 0. How about the amplitude?
1.
How about the period?
2 pi.
2 pi. Okay, so our function will be, the amplitude is 1, and the graph is the graph of sine or cosine?
Cosine.
That's cosine. The period is 2 pi, so the coefficient of the angle will be 1. Right? So this is cosine x, and because the center is 0, that's plus 0. In other words, y equals to cosine x only. Now, how about number 8? What's the center?
0.
How about the amplitude?
2.
How about the period?
2 pi.
2 pi. So this will be y equals to 2. Is it sine or cosine?
Sine.
That's a sine. And the period is 2 pi, which is 2 pi over 1, which means the coefficient of the angle is 1 and plus 0, right? Or just y equals to 2 sine x. How about number 12?
0. This is the center.
Center is 0. How about the amplitude?
1.
Is it sine or cosine?
Cosine.
That's a cosine shape. How about the period?
Pi.
So it must be 2 pi over 2, right?
Yes.
So y equals to 1 cosine 2x plus 0, or simply y equals to cosine 2x. We started at 7:16, right now 7:20. We already done with 3 questions. Okay. Yes?
Questlove, correct. Solar lecture is 1200. John Cleese of this comment.
Okay, you try number 16. I'll give you 1 minute. Okay, number 16, the center is,
0,
the amplitude is
3,
3, and then the period is,
pi,
okay, is it sine or cosine?
sine,
That's sine. So y equals to 3 sine what?
x,
Are you sure? Sine
2x.
2x. Okay, so we need to write that as 2 pi over what to get the coefficients of the angle. And because the center is 0, then we don't need to add anything. Let's go even further. How about number 20? Center,
0,
amplitude,
2,
the period,
2,
2, so that's 2 pi over pi, right? Okay, and
Yes.
then the shape is sine or
Negative.
cosine?
negative cosine,
That's negative cosine, good. So when we put them together, this is y equals to negative 2 cosine what?
pi,
Pi x. Okay, now let's make it harder. We like it harder. Number 22. What's the center?
1,
No,
3,
that's right. How do we get that 3? The center is the midpoint of the maximum and minimum. So maximum plus the minimum divided by 2 will give you that center. Okay, now how about the amplitude?
2,
2. And then how about the period?
2,
So that's 2 pi over pi. And the shape is sine or cosine?
negative cosine,
Negative cosine x shape. So when we put them together, this is y equals to negative 2 cosine pi x plus 3. Or sometimes in my test, I write the constant first, 3 minus 2 cosine pi x. Now, so far, the problems we dealt with has no phase shift. It always start from the y-axis. Now, starting from number 24, that's not the case. Number 24, the center is 0. The amplitude is 2. Okay, the shape is the sine x. How about the phase shift? Where do you start?
pi over 6,
Pi.
Yeah, pi over 6. Okay, how about the period? Not 5 pi over 6. The period is 5 pi over 6 minus pi over 6. That's 4 pi over 6. That's 2 pi over 3. Okay, so if I put everything together, then y equals to the center is 0 plus the amplitude 2 of the shape of sine, and then the period is 2 pi over 3, which means the coefficient of the angle is 3 times x minus phase shift. If I simplify, this is 2 sine of 3x minus pi over 3. Okay, you try number 24, I'm sorry, number 26 and 28. Number 26 and then number 28. Number 26, the center is 0, the amplitude is,
3.
and the shape of the graph is
Negative sine.
negative sine shape. How about the phase shift?
Pi over 4.
Pi over 4. How about the period?
Pi.
That's pi, which is 2 pi over 4. 2 pi over 2, right? So from here, then the function or the equation is negative 3 sine 2 of x minus pi over 4. Which, if I distribute the 2, I get negative 3 sine of 2x minus pi over 2. Okay. Number 28, the center is
Negative 2.
center is negative 2. How about the amplitude?
2.
2. And then the shape is the shape of sine x. The phase shift is
Pi over 6.
pi over 6. And how about the period?
2 pi over 3.
2 pi over 3, which we get from 5 pi over 6 minus pi over 6. Okay, so putting them together, we get y equals to negative 2 plus 2 sine what?
3.
3 times x minus pi over 6, which will be y equals to negative 2 plus 2 sine 3x minus pi over 2. Okay, now suggested homework from here. We do number, I would like you to do from number 5. This is 4.4. Number 5 to number 27. Just do the odd ones. Okay, right now it's 7:32. We actually start at 7:16. We finish one section in 16 minutes. Not bad, huh? Yeah, Thomas. Well, that's because you already did the graphing, okay? And so if we know the graph, we will be able to go find the equation easier, okay? Now I will go on with the next section. I will skip 4.5. I go on to 4.6. If 4.4 on the easy side, then 4.6 on the hard side.
Can you go over number 26 on 4.4?
Oh, here.
On 26 for, how'd you get negative 3?
Negative 3. Oh, it's because of the amplitude is 3, right? But the shape of the graph is negative sine.
Okay.
Yeah. Okay, so that's why we get that negative 3 here. Negative 3 sine. That's the reason. Okay, 4.6. This is on the hard side. Inverse trig functions. I will first talk about the sine inverse function. So let's call that part A. Inverse sine function. Now we have known that sine function looks like this. So sine function looks like this. It looks like this. And then it goes forever there and even go backward too. Okay, and the period is 2 pi. Now, the problem with sine function that makes this section on the difficult side is for us to get inverse function, the function has to be 1 to 1. While sine function is not one-to-one. What is one-to-one, Thomas? One-to-one is this. A function is one-to-one if you have the graph, then every horizontal line hits the graph only at one point. That's a one-to-one function. While here, as you can see, if I draw a horizontal line, the line will hit the graph at multiple points. You see that? It hits at this point, this point, this point, and actually infinitely many points. Okay, so sine function is not one-to-one function, and therefore it's actually not eligible to talk about the inverse function. Let me redraw it again. Now, for us to make it one-to-one function, then we will do something called restricting the domain, in which I restrict the domain from negative pi over 2, from negative pi over 2 to pi over 2. Now, notice that in this interval, negative pi over 2 to pi over 2, the function is one-to-one, which means every horizontal line that I draw, if it hits the graph, it will hit it at once, at only one point in that interval. So here's what happened. Here's what happened. If y equals to sine x has domain or real number, we will restrict the domain to negative pi over 2 up to pi over 2. Which, if you think about that in coordinate system, that's 0 to pi over 2 is here. That's quadrant 1. Okay? But negative pi over 2 to 0, that's quadrant negative 1. Okay, some people call that quadrant 4. I prefer to call that quadrant negative 1, at least for now. At least for now. Okay? Now, once we restrict the domain to this negative pi over 2 to pi over 2, then y equals to sine x is now a one-to-one function. And therefore, then we can define inverse function. Inverse sine function. Okay, let's have some feeling about inverse sine function. Okay, suppose, for example, I need you to memorize something. Suppose I have sine pi over 3. What is sine pi over 3?
It's 60 degrees.
Pi over 3 is 60 degrees. So what is sine pi over 3? That's radical 3 over 2. Now, inverse function will do the following. Suppose you tell me the value, if the input is the value, the output is the angle. Okay, so let's see again. How about sine pi over 4? Sine pi over 4 is radical 2 over 2, that's 45 degrees, right? Sine 45 degrees radical 2 over 2. Now, how do I write it in inverse sine? Inverse sine will be sine inverse of the value. The output will be the angle. Now, with that said then, what is sine inverse of 1/2? What is the angle? What is the angle such that sine of that angle is 1/2?
Pi over 6.
Pi over 6, that's right. The reason it is pi over 6 because sine pi over 6 is 1/2. Okay, now that's for the positive value. The problem is what happened if I ask sine inverse of, let's say, negative 1/2. Now, don't forget that the restricted domain, the domain of the sine function, for us to be able to talk about sine inverse, has to be in quadrant 1 and quadrant -1, where sine of quadrant 1 is positive, sine of quadrant -1 is negative. So the answer here should be quadrant -1. Okay, now sine what is -1/2. And that has to be in quadrant -1. Sine negative angle what equals to -1/2. You will see the negative angle there has to be negative pi over 6. Okay, now for us to answer this question, we're supposed to ask the following: sine what angle equals to -1/2? Now, as we know, there are a lot of angles that give us -1/2. For example, sine sine 7 pi over 6, sine 11 pi over 6, and a lot more. The problem is 7 pi over 6 and 11 pi over 6 are not in the restricted domain. There are a lot of angles such that sine of that angle is equals to -1/2, but there's only one angle in this restricted domain. There's one angle that is in this restricted domain such that sine of that angle equals to -1/2. And the answer is -pi over 6. Now, for sine inverse case, we can actually think the following. Sine inverse of a negative value that's equals -2 of sine inverse of x. You can use this to help you finding the value. Okay, so if I go on a bit further, suppose, for example, what is sine inverse of negative radical 3 over 2?
Can you repeat that?
Sine inverse of negative radical 3 over 2. This question here.
Sine negative pi over 3.
Pi over 3. So sine negative 3 pi, negative pi over 3 give us negative radical 3 over 2, right? And negative pi over 3 is in the restricted domain. So the answer here will be negative pi over 3. Okay? Now, notation. The notation sine inverse of x, usually also written as arc sine of x. Okay, now I would say that this is a more modern notation. And this is the older way to write it, not so recent. Okay, but we still see a lot of arc sine notation in our textbook, which is a good thing. More and more, we don't see this arc sine. We tend to see the notation with this inverse here. This inverse here. In old time, they write it as arc. But our textbook still use both of them. Even the calculus textbook we use still use both of them. Okay. What we learn from here is the important one is the restricted domain. Why do we need to restrict the domain? Because sine function is not one-to-one until we restrict the domain to negative pi over 2 to pi over 2. Now that's for inverse sine function. The second one, inverse tangent function. You will see tangent inverse of x can also be written as arc tan of x, just for the purpose of notation. Now the graph of tangent x, give me maybe a couple seconds. This is the graph of tangent of x. Now the thing is, like I said before, tangent of x, just like other trig function, is not one-to-one, because when I draw a horizontal line here, it will hit the graph at multiple places. You see, so it's not one-to-one function. However, if I restrict the domain, from negative pi over 2 up to pi over 2, the same restriction to sine, and all of a sudden the graph of tangent x in that domain is one-to-one. Okay, the graph of the function in that restricted domain is one-to-one. One of you, can you mute that, please? Is it a soccer? You make me want to watch it too. Well, so we will restrict our domain now from negative pi over 2 to pi over 2 such that the tangent function is 1 to 1. Y equals to tangent x restricted to negative pi over 2 to pi over 2. Okay, to make it 1 to 1. That way, then we can talk about tangent inverse. For example, you think about this, what is tangent inverse of 1? I don't need parentheses, but I can, but I just don't need it. What is tangent inverse of 1? Now, the way you think is tangent what angle equals to 1?
2 pi?
No,
Pi over 2?
no,
1.
no.
Pi over 4.
Pi over 4, that's right. Okay, there are actually a lot of angles such that tangent of that angle is equal to 1. One of them is pi over 4. The other one is 5 pi over 4. Okay, now the problem is 5 pi over 4 is not in the restricted domain. That's why we use pi over 4 only. How about tangent inverse of radical 3?
Pi over 6?
That's pi over, no, I don't think so.
Pi over 3?
Pi over 3. Okay, how about tangent inverse of 0?
Two pi?
Nah, tan 0 equals to 0, right? Yes, that's true. Tangent 2 pi also 0. Tangent 2 pi also equals to 0. Now the problem is 2 pi is not in the restricted domain. Yeah, 2 pi is not in the restricted domain, negative pi over 2 to pi over 2. Actually, I make a very fatalistic mistake. I should not use bracket there. I should use parentheses. I should use parentheses instead of bracket here.
Why?
Because pi over 2 and negative pi over 2 is not in the domain of tangent anyway, to start with.
So you can use pi over 2, is what you're saying?
Yes, that's what I'm saying. We cannot use pi over 2. And actually, if you think about it, what is tangent pi over 2?
Undefined.
That's undefined. That's why pi over 2 is not in the domain. Therefore, there is no value. Therefore, tangent inverse of whatever you put here can never give you pi over 2. Never. And once you tell me what number here, once you tell me what number here, it will never be pi over 2 because tangent pi over 2 is no such number, right? You see? So I cannot put whatever number I put in here, then the output will not be pi over 2. Okay? Next one, how about if we deal with negative angle, tangent inverse of, let's say, -1. So you ask yourself, tangent, what angle equals to -1, while that angle has to be between negative pi over 2, sorry, negative pi over 2 to pi over 2.
Negative pi over 4.
Negative pi over 4, that's right. In fact, for tangent inverse, we have the same property like sine inverse. Tangent inverse of negative x is equals to negative of tangent inverse of x. Okay? Maybe I box that so that we remember. So tangent inverse of negative x is negative of tangent inverse of x. The same with this guy here. The same with this guy here. That guy has the same idea with this guy. Okay, now to talk about that further, you see the reason is because sine function and tangent function, sine function and tangent function are both odd function. Hold on, I'm sorry. By the way, what did I do? Did you see my lecture? Did you see my board?
What do you mean?
Do you see what I'm writing here?
Yeah, tan -1. Where your mouse is right now is the example where it says tan -1 root 3 equals pi over 3.
Oh, okay. Because because what I just saw is like my video is not working. What are you seeing now? What I'm pointing at here?
The
number 2.
Number 2. Okay. So you saw that earlier. That's fine then. Okay. Now, so that's because from the past, the reason why this works is because from the past, I think that's basic property number 4 or number 5. That sine of negative x equals to negative sine x. And then tangent of negative x equals to negative tangent x. Have you seen this?
Yes.
Basic properties or basic identities. And I think this should be identity number 4. Basic identities number 4. And this is 1. The second one is cosine negative x is equals to cosine x. While tangent negative x is negative tangent x. Okay, so you see that sine and tangent, you pull the negative out. Can pull the negative out. Now that situation make these two properties apply. The yellow box here for sine inverse and the yellow box here for tangent inverse. Okay, unfortunately, that's not the case for cosine. Let's see what is the graph of cosine function first. Second. That's the graph of cosine function. And just like before, this cosine function is not one-to-one because I can easily find a horizontal line that hits the graph at multiple points. Here, 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 here. So we cannot do cosine inverse until I do restriction. And the restriction for cosine inverse will be from 0 to 2 pi. I'm sorry, to pi. That will be the restriction. From 0 up to pi. Notice that in this interval, the cosine graph is one-to-one. In this interval, the graph of cosine is one-to-one. So you will see y equals to cosine x will be restricted to 0 to pi. To make it one-to-one. Therefore, when we do cosine inverse, the answer should be from 0 to pi. Let's say, for example, what is cosine inverse of 1? So you ask yourself, cosine what equals to 1?
0.
Cosine inverse 0 cosine 0 equals to 1. So cosine inverse 1 is 0. Okay. Now, how about cosine inverse of 1/2? The way we answer that, cosine what equals to 1/2? What's that?
Pi over 4.
I don't think so.
Pi over 3. Sorry.
Pi over 3, that's right. So cosine inverse of 1/2 is pi over 3. Now the thing is, what happens if we have negative angle, negative value? Let's say cosine inverse of negative 1/2. Now the answer is not negative pi over 3. No, it doesn't work like sine inverse. It doesn't work like cosine inverse. Okay, because what? The restricted domain for cosine is from 0 to pi. So the answer will never be negative. Okay? Now, then the way we think will be as the following. Cosine what? And of course, it has to be in quadrant 2. Give us negative 1/2. What's the reference angle? Cosine what give you 1/2?
Pi over 3.
Right? Now, if that's the reference angle, what will the angle be in quadrant 2?
4 pi over 3.
Quadrant 2. Pi minus pi over 3. That's 2 pi over 3. One way to help you, you can think of it this way. Cosine inverse of negative value equals to pi minus cosine inverse of the positive value. Okay, now right now is 8:04. I will give you 10 minutes to do some problem, and then together with that, another 10 minutes for break. I would like you to work on try question number 6 all the way to number 24 on page 227. Do even number. We will be back at 8:25. So together with your break, we come back at 8:25. Okay, let's start. Number 6. Cosine inverse of 1/2 is, I think we did that earlier.
Pi over 3.
Pi over 3, that's right. Number 8. Cosine inverse 0 is
Pi over 2.
pi over 2. Tangent inverse 0. What am I doing? Tangent inverse 0 is
0.
0. Number 4. How about arcus cosine of 1?
0.
That's 0. That's right. Number 14. Sine inverse of 1 over radical 2.
5 over 6.
No, I don't use pi over 6. That's for 1/2. What's that?
Pi over 4.
I have 4, that's right. Number 16. Arctangent of 1 over radical 3.
5 over 6.
That's pi over 6. Number 18. Arc sine of negative radical 3 over 2. This must be negative. And then the angle will be pi over 3.
Yes.
Number 20. Tangent inverse of negative radical 3. That must be negative of, I think,
Pi over
3
3.
also. Number 22. Sine inverse of 1 is,
It can't be pi over 2, right? Because of the domain.
it is actually okay. It is actually okay. Because the restricted domain for sine to make it 1-to-1, the restricted domain for sine to make it 1-to-1 is negative pi over 2 to pi over 2, including the endpoints.
So this includes, only cosine is when it isn't included.
Only tangent inverse. Only tangent inverse, not including the endpoints.
Yeah.
Okay. And number 24, how about arc sine of negative 1?
Negative pi over 2.
Negative pi over 2. That's good. Okay. Now, I would like you to do some problem from the book, this time using calculator. For example, number 26. Number 26, sine inverse of negative 0.1702. Now, the way you punch this on your calculator, you need to look for that second button first. Now, and then that's because for the sine button, you need to get the one above that, the sine inverse button. take a look on your calculator. And then you punch in negative 0.1702. Now then go ahead, use your calculator. The answer will be negative, we know, but we don't know negative what angle. Here I get negative 9.7994 degrees. So the answer I gave you earlier from number 6 to number 24 and even before that, all the answers were in radian. This time, when you use calculator, you can actually choose your answer to be in radian or in degrees. Now, I believe if you use your calculator right now, the mode must be in degrees. Can you confirm you get this answer?
Yes.
Everybody? Now, because of that, then let me ask you to try number 28. This is more into practicing how to use calculator. Number 28 and then number 36, please. Number 28, I get 32.59494 degrees.
Yes.
Okay, and then arctangent of negative 0.3640, I get that's equals to
Negative 20.00015.
negative 20.00151.
Yes.
Okay, that's if we need to use calculator. We will need to use this calculator much later when we deal with chapter 7, as I remember. If not 7, that's 6, but I think it's chapter 7. That's much later. But the one we need to focus more right now is what if we have compounding situations? Let's say, for example, this seems to be hard. Suppose I want to find sine of cosine inverse of 2/3. And we need to do this without calculator. We need to do this without calculator. This is the way we will do it. Okay, write down the question first, and you will see that this, when we compute this, do we get a value or do we get an angle?
Angle.
That will be an angle. So I will call this theta. Okay, let theta equals to cosine inverse of 2/3. The way I teach you here is to anticipate what you will see later on in calculus 1 and calculus 2. Okay, so it may look slightly different from the way our textbook doing that, but I think our textbook doing it this way. The different textbook, the one at Santa Monica, as I remember, they do it differently. Okay, so I will let theta equals to cosine inverse of 2/3. So cosine theta equals to what?
48.18
Nah,
times.
no. Oh, I'm not asking the theta. I'm asking what is cosine theta.
2 over 3.
2 over 3. Okay, because if you use calculator, you lose the accuracy right away. It's not exact anymore. Now cosine theta equals to 2 over 3. Therefore, is it okay, everybody, how I go from here to here?
Yes.
Okay,
Yeah.
so I rewrite the cosine inverse becomes, I rewrite the cosine inverse, I move it to the other side, it becomes cosine without cosine inverse. Okay, now then, once we get that cosine theta equals to 2 over 3, then I draw the triangle. I draw a right triangle with angle theta on one of the angle. Now cosine theta is 2 over 3 means this has to be 2, this has to be 3. I'm sorry, that's wrong. It should be 2 here. Okay, so from that cosine theta equals to 2 over 3, I feel that from the triangle point of view. Now then, what will this be? Apply Pythagorean theorem. What's that? That's square root of
5.
5. That's square root of 9 minus 4. That's square root of 5. Now, what we need in our question is we need to find sine theta, because I replaced this by theta, right? I need to find sine theta. Sine theta, according to that triangle, is what? Radical 5
Over 3.
over 3. So basically, we already answered sine of cosine inverse of 2/3. That's equals to radical 5 over 3. Okay, now let's do one more before I ask you to do problems from the book. Another one, let's say I have cosine of tangent inverse of, let's say, 3. So what is my first step?
Let theta equal tangent -1.
Tangent inverse of 3, okay. Therefore,
Tangent equals to
tangent theta
tangent
equals,
theta.
Equals to what?
3.
3, which I can write as 3 over 1. Okay, then I draw the triangle, I draw the right triangle. Let's say this is theta, and therefore 3 over 1, this is 3, this is 1. That gives us a tangent, right? Okay, so what is the hypotenuse? Repeat again. What's that?
Radical 10.
Radical 10. That's square root of 3 squared plus 1 squared. That's radical 10. Now what I need is the cosine of that. Cosine theta equals to 1 over radical 10. That's radical 10 over 10. Therefore, cosine of tangent inverse of 3 equals to radical 10 over 10. Is it okay?
Yeah.
Now, let me ask you to do problems from the book. I would like you to do maybe 3 problems. From page 228, I would like you to do number 64, and then number 68. Maybe only 2 problems, good enough. Okay, 1 problem takes 3 or 4 minutes, 2 problems, let's say around 2 minutes. I mean, around 8 minutes. Okay, you try. Number 64, cosecant of tangent inverse of 3/4. So we call this theta. So let theta be tangent inverse of 3/4. So tangent theta is 3/4.
Special triangle.
So we do the triangle now. So let's say this is theta, then this is 3, this is 4. What is the hypotenuse then?
5.
5. That happens to be a Pythagorean triplets, right? And then
Yes.
we need the cosecant. Cosecant theta equals to
5/3.
5/3. Therefore, let me scroll that up further. So cosecant of tangent inverse of 3/4 equals to 5/3. Number 68. Number 68, sine of cosine inverse of 1/radical 5. So we call this theta. So let theta equals to cosine inverse of 1/radical 5. So cosine theta equals to 1/radical 5. Do the triangle. This is 1, this is radical 5, so this is 2.
Yes.
Okay, so sine of theta will be 2/radical 5.
Do we rewrite it?
We should. So sine of cosine inverse of 1/radical 5 is 2/radical 5. Rationalize 2 radical 5 over 5. Okay, we are almost done with this section. Let me give you one harder question. And then after this, I will do easier question. A lot easier. A lot easier. The harder question is, for example, suppose I ask you what is sine of tangent inverse of x. Now, we will do the same procedure, actually. The difference is earlier we have numbers on this position here. Right now it's an x, okay? But the idea is still the same. Let theta equals to tangent inverse x. So tangent theta equals to x, or we can see that as x/1. Then from there, we draw the right triangle for theta. This is x, this is 1, then this will be square root of x squared plus 1 or 1 plus x squared, either way. Okay, such that then sine theta equals to x over square root of x squared plus 1. So sine of tangent inverse x equals to x over square root of x squared plus 1. Okay, now this type of question, repeat again.
Should you rationalize that one or no?
if you have time, do it. Usually at this point, I just like, hey, you know what, you get it right. Okay, but if you're kind of aware of that, just rationalize that. Okay, you can ask me that question during the test though, but the way I see is this: rationalize whenever you can, right? It's never wrong anyway if you rationalize that. You see what I mean?
Yeah.
But I have to admit there are times that it seems to be too complicated when we rationalize that. So I don't mind you stop there. But the rule of thumb is rationalize, because if even if I don't need you to rationalize, I don't penalize you unless you do it wrong, totally wrong. Well, anyway, that's the harder part. How about the easy one? The easier part is the following. What happens if I have, for example, sine of sine inverse, or cosine of cosine inverse, or tangent of tangent inverse? Now, whatever that is here, they will cancel, because sine cancels sine inverse, cosine cancels cosine inverse, tangent cancels tangent inverse. Let's say this is 1/2 here. Okay, so this will be 1/2. Why? Because the sine cancels sine inverse, cosine cancels cosine inverse, tangent cancels tangent inverse.
What if it's cosecant and sine?
Then we have to do it the way we did earlier. The way we did this. You see? Okay. Only when they are exactly the same trig function, sine inverse, then they do cancel. Even though we need to be a bit careful with the with the sneaky part, like very. If you see this question in my test or my quiz, I'll just try to be very sneaky on you. For example, cosine of cosine inverse of 2. Now, this is not equal to 2. Why? Because cosine inverse of 2 has no solution. You see what I mean? Suppose this is theta, right? Suppose this is theta, then theta equals to cosine inverse of 2. It means cosine theta equals to 2. But there's no solution for this. You see what I mean?
Yes.
So in other words, if I summarize that, sine of sine inverse of x, or cosine of cosine inverse of x, that's equals to x. In other words, the sine cancels the sine inverse, cosine cancels cosine inverse, only when x is between -1 to 1. It has something to do with the range of sine and cosine. Okay. Now for tangent, however, there's no restriction, because the range of tangent is all real numbers. So tangent of tangent inverse of x equals to x for any x. Okay. Now notice that for this example, the trig function is outside, the trig inverse is inside. Now compare that to, let me put it here. They look very, very similar, but they are not. Compare to, suppose I do the following. Sine inverse of sine 30 degrees. You see in the last expression here, the inverse is outside and then the trig function is inside. Now, when you do this type of question, do it inside out. Don't do canceling. I prefer you to do, this is sine inverse of, what is sine 30 degrees? That's 1/2, right? So sine inverse of 1/2 is pi over 6. Hold on, Thomas. You see, if I cancel sine inverse and sine, I get 30 degrees, which is pi over 6 anyway. That's true in this case. But that's not the case if I make that 30 degrees becomes 150 degrees. Sine 150 degrees is still 1/2. Okay, so sine 150 degrees equals to 1/2. Sine 30 degrees also equals to 1/2. But sine inverse of 1/2 is always pi over 6. So in this case, the sine inverse don't cancel sine. Okay, you cannot just cancel it right away. So not 150 degrees. The answer is not 150 degrees. Basically, if you have trig function inside, then do it inside out. If you have inverse function inside, then see if you can cancel. Okay, like in this case here, like the case we have here. If we have tangent inverse inside, see if we can cancel. Okay, but if you have trig function inside, just do it inside out. Okay, what happens if you have trig function inside, but the functions are not the same? Then do it long way. Okay, now, so your suggested homework from here will be, from this 4.6 will be number 5 to number 37, and then number 45 to 83. 45 to 83. Just do the odd ones. Now it seems like this it has a lot of problems here. It's like around 30 problems, but each one of them is actually quite short. Okay, so let me ask you, please do this suggested homework from this 4.6. 4.4 is on the easy side, so I believe you can do it easily too. On Wednesday, I will start working on 5.1 and 5.2. The material for your test 2 will be up to 5.1. Let me write it down. Your test 2 will be from chapter 3 up to 5.1. Okay, even though on this Wednesday, we will do 5.1 and 5.2.